So for this experiment, we isolated alum from aluminum, and we created alum crystals before dissolving it in a supersaturated solution and observing the growth. So this is the first week, and we just created these. So we used a couple of processes to convert aluminum into alum crystals. So the first process was to dissolve the aluminum foil using potassium hydroxide. So we utilized 4 molar potassium hydroxide, and we dissolved all the aluminum and took out the any solids that were remaining. And then from that step, we after that we used sulfuric acid, 9 molar sulfuric acid, so very strong sulfuric acid, and we used that to precipitate out a product before redissolving the product, to precipitate out before redissolving the precipitate, the product, and we redissolved it using excess sulfuric acid and heat, and that allowed for the particles to once again be dissolved before being introduced to an ice bath and then solidifying in the end, which is step 4. So we used an ice bath to push this reaction and create solid alum crystals, And so the alum ended up looking like that, and then we took it and we dissolved it in water to make the supersaturated solution on the right. And so this crystal growth is actually it's actually pretty much grown none at this point. It's still very new. I did the lab about 3-4 hours ago. And so to grow salt crystals, I would first take table salt, and dissolve it into, or sodium and chloride by themselves in ion form, add it to water, and add it to specifically distilled or deionized water, and then heat this up until it's boiling, so that the solution is completely dissolved, so that everything's dissolved in the solution, and then allow this solution to cool to form the crystals, or introduce it to ice and cool it very rapidly to form crystals faster. And then in terms of growing crystals using other techniques, this lab specifically for alum was used supersaturation as the technique, and nucleation. And there are other crystallization techniques such as sublimation and convection that could really grow we could really grow bigger crystals and quality crystals that don't necessarily use this technique. And so from MIT's actual website, their Department of Chemistry, they show these different techniques, and sublimation, of course, would require the compound to be able to move between the states would have to sublime. It would have to skip the liquid phase. The sublimation technique can't be utilized. Convection can be utilized, and so using a gradual temperature gradient in the vessel, it will allow for a slow liquid phase, and then after that it will dissolve and then recrystallize in the colder region. So this is a very similar process as our process, but in a much more controlled setting, in a much more closed setting, which can result in better crystals and higher quality crystals.